Hello and welcome to the screencast, Elements of Life. This is on nuclear and radioactive decay. So let's get started here. Nuclear reactions. What happens is there's a change in the nucleus, which equals nuclear reactions. Can change one element into another element. Some of these reactions are spontaneous. Some require massive amounts of energy to take place. All right, so we have some examples here. This is an example of an element breaking down into two different nuclei. Here we have a helium atom, and then this is thorium, I believe. Yes, is thorium. Okay. So this uranium emitted this helium particle, which is an alpha decay, and it created this thorium as well. All right. Also, we can have breaking down a larger element, such as uranium, into two other components that we see here. And this is the example of what is taking place in a nuclear reaction. So this is splitting into smaller nuclei or different atoms. You can see that we have uranium-235, then we go to U-236 for uranium, and then we get these other smaller different types of atoms. And this is what we can look at is occurring inside of a nuclear reactor here. You have the core area here where you're going to get these nuclear chain reactions occurring. That essentially just heats up water that goes over here as steam and then turns a turbine. And that turbine generates electricity that we put out to the electrical grid. And then this example down here is the joining of two different atoms together. Deuterium and tritium are forms of hydrogen that bond together to form helium, and then they emit this neutron over here, and it creates this huge amount of energy, and this is what is occurring inside the sun right here. Okay. So again, we can split into smaller nuclei. We can combine with another nucleus or particle, and that's what the example showed. It can only happen under certain circumstances, so spontaneously in radioactive elements such as uranium or plutonium, maybe you've heard those before, and can be made to happen in a nuclear reactor or as I demonstrated with the stars. Okay. Here's what they look like. We have alpha, beta, and gamma. These are the three ones that we're going to focus on throughout the course. In an alpha decay, you're basically ejecting or emitting a helium atom. This is the symbol that you would associate it with it, and then this is the atom that is being released. It has an atomic mass unit of 4. It has a charge of a +2. And the interesting thing is that an alpha particle could be blocked by a sheet of notebook paper or clothing. It's a very weak emission. This is happening all around us. Then we go into beta decay, which is the emission of an electron. The symbol is with this B with this little tail that comes down. You virtually have no AMU. I mean, an electron is very, very, very light. We just consider it as 0 for our purposes in this class. It's a negative charge, and you can stop this with a very thin sheet of lead. Gamma radiation is a little bit different. This is the emission of radioactive or emission of a electromagnetic radiation as the form of a photon. So it's like sort of like a beam of light that's being given off. The interesting thing here is that what we'll find out is that the protons and neutrons of that element stay exactly the same. You can see that we've increased the size of the lead here. This is relatively thick if you take out a ruler and look at what 10 centimeters looks like. This is a sizable or a pretty powerful form of energy that can be emitted from decaying radioactive material. The process of ejecting or emitting pieces of the nucleus is what we call radioactive decay. And we have those three types that we've just described, the alpha, beta, and gamma. And what we're going to do is just show you some equations and what it looks like in a practical sense. So, types of decay, we have alpha. We have a loss of an alpha particle, which is this symbol right here. And we decrease the atomic number by 2 and the mass by 4. So we have uranium-238 here. So that's the atomic mass, the 238. This is the number of protons here. And you can see that we reduced the number of protons to 90, and we reduced the atomic mass to 234. All right? And that is the new thorium atom. And then we have the emission of a helium atom. If we look and contrast it with beta decay, here's the symbol associated with it. So we're releasing an electron. So what happens is we increase the number of protons by 1 in this example. So we have iodine here, and then we go to exon, and you can see that the atomic mass stays the same, but we increased in exon the number of protons as described by this description right here, and then we have the emission of the electron. And then the last one looks at alpha decay. So a loss or emission of electromagnetic radiation in the form of a photon. This is the symbol. All right, number of protons and neutrons stay the same. So this is iodine, and this is going to be a plus or an asterisk to indicate that this gamma decay. And what you should be able to see here is that iodine, it doesn't change. Like if you look at those other examples, we went from one type of atom to a brand new type of atom. In this example, we still have iodine, but what we're kind of eliminating as this reaction occurs is this little, asterisk here, or positive energy that it has. Okay, so the atomic number stays the same, the atomic mass stays the same, and then you have the emission of the gamma particle, which is a photon, so it should give off some light or energy associated with it. So it's a very quick and easy rundown of different types of nuclear reactions, some pictures associated with them, and then some of the equations that you might see in your practice problems. So I would definitely look at the types of decay slides. That would be 7 and 8, and use those as references when you solve some of the workbook pages for this unit. So thanks for taking time. Again, take notes, write down a couple questions for your teachers, and ask them about those questions in class so you understand this information. Have a good day.